Okay, you're live here. Hello. Almost 4. In about 2 hours. We just want to figure out whether we can get some sort of train on world model thing to work. Odd. Very, very odd. The fact that this didn't work. So I tried to be fair, I didn't actually try this for very long. I tried to give it the real OBS action data, and it still didn't work. Seems very off to me. Try this. Even if this works, it's not going to tell me very much, right? Hmm. I mean, this is like barely better than trivial. That's with one step. How could this possibly be the case? So literally here, we could say it could be the rewards and terminals. We could say that, right? Now it's literally just the one-step OBS predictions, right? So odd. Something's just gotta be off. The way this thing is behaving. This does not make any sense to me that this is possibly so bad, right? Like we have the real data version. Welcome YouTube folks. Got the real data version. And then it starts to take off. I suppose, though, that unstable bit at the start really makes this a tough environment to play around with, right? Because you're literally not going to see anything until it really works. Hey, welcome. The thing I don't understand, though, wait, is it actually like this in the full case? If I just comment all of this crap, right, and I just put this here, I think it was. It takes 10 million steps, it says. 10, 12 million steps. And then if I do logits, new values, if I do this version, see if it takes 10 mil. Okay, so this is weird, right? This really doesn't seem to be behaving identically to me. If I missed something. This one here, you got state, jobs, and state, and logits, action, right? Here, value, action, null. This seems like it really should be identical to me. Just throwing me for a loop. This should be identical. There's some like bizarro stability thing. Sense. Just noise? Doesn't seem like it. Take off until like 20 mil. And even then it's more unstable. A fan of that. Difference, right? This. Oh wait, what? Okay. Fine. Yeah, okay, like fine, I guess. I'm trying to think what steps I can take here. I guess what we can do. Try something. I'm gonna do like this. This. Okay. Now. What else? No. Try this. Literally just has to predict the next observation, nothing else. I mean, if this doesn't work, then like... this is just way too fiddly, I suppose. Like, the base method is too fiddly if this doesn't work. I'll have to work on figuring out why the base method. Seems like that's the case. See if we can get a better duration. Naturally, this is going to be more. Hey, Weston. Oh, that's way worse. P. Nope. It's stable, it just takes a while, right? Okay, well, this actually does get it a little faster. Probably makes the convergence worse, but we'll do this for a little bit. See if we can get the new data model. See this one. Okay, that one works. Very nice. This is the new data, new real data. Okay, so now we can go from this to variations on imagined data with slightly more confidence than before. Okay, so this is the one-step model. This not working seems... Oh, we're not RLing the world model, dummy. Training the world model. It's not working. So implausible to me. This, like... completely implausible unless I've actually done something wrong. Or I'll go. The world model is a supervised learning. It's learned, it's supervised learning, and it's predicting the next state so that we can do RL on the world model. So it's neither, really. An auxiliary to the RL algorithm. That stands in for the real environment. Jobs. Maybe we need to do this. There's no way that some form of this doesn't. No way at all. Okay. One-step observation predictions only. Meeting is fine, Jess. I do so hate to break up my day with meetings, though. Entropy has crashed. How the heck? How the heck is entropy crashed? Seems bizarre. Does it not seem bizarre that the entropy is that crashy? Hmm. UI is so much satisfying. Yeah. I like the puffer UI. I added the fish swimming in 3.0. I thought it would be amusing. Ah, there we go. So that's only a one-step observation prediction. Quite unstable as well. Something, though. Very unstable. The only thing that this is doing is using one step worth of hallucinated observations. He is so low is weird. Level of performance mean. Good. I mean, it means that there's like a big gap that's being caused by purely the single step prediction and nothing else at the very least. Which seems bizarre to me. Data. Yeah, it works. We should double check just to be sure that with this high entropy, that it still works. It's possible the entropy screws it over, we'll see. No, look at that. So literally the only difference being the OBS prediction of the world model. Literally the only difference. We discussed, or Alcina is starting digging into Pupper again. I was surprised to see Pokemon Red M as part of Pupper Tank due to provide wrapper to reach faster SPS. Yeah, Pokemon's a decent bit faster with Puffer than outside of Puffer. Like, we can't obviously make it anywhere near as fast as our other environments. I think people were getting somewhere between like 7 and 9,000 steps per second training or whatever. We were on that project. It's mainly just our multi-processing is faster and our training is lower overhead. You don't get as much benefit because of how slow the env is to begin with. There's no way I've done this reconstruction loss wrong, right? You know what? Just for the heck of it. Crazy. Like moderately ridiculous, right? Thing. I'm pretty sure that the other way doesn't do anything either. Model are you using? You can see it. It's just I just have some basic encoder decoder. 25% breakout on Atari breakout or on Puffer breakout? Puffer breakouts should be like stupid fast. I get up to 4 million step per second training on breakout. I don't believe for a second just like you have to have RSSM or some bullshit, right? Maybe you do need memory though, right? I wouldn't be surprised if you do. Like, you literally do need memory to know what way the ball is going, don't you? That's probably bad. Yeah, it's kind of tricky to do that, unfortunately, Peru. Station. Yeah, it should be quite fast, normally. Like, at least like a million or whatever, even on low-end hardware. Yeah, because you can't train the world model without having you can't train the world model without having data. Like, what, you're gonna train it on the like breakout failing to break any bricks? Like, that's not usable data, right? Yeah, 3.9 mil is about close to as good as it gets. The current settings. Build the data with a random agent. If you build the data with a random agent, yeah, then it's not going to be any good data, right? That'll work on like cartpole, but that won't work on anything at all more complex. Like you can't train a world model without an agent. Can't train the agent data efficient without the world model, so which came first, the chicken or the egg? And no, I don't care if that question has an actual scientific answer. Honestly, all the ones I've heard are stupid anyways. The theme of the stream. Ah, I know. What is wrong with this stupid? Go work. Why not? Am I like... Oh. I don't know how that happened. That was weird. Must have, like, deleted a character without realizing. Well, it has memory now. Doesn't seem to do much for it. Has it? Hmm. Eh. This is still the one step, like, what should be super easy task. Not crushing it either. This seems just, like, really bad to me in general. Noxious. It's crazy to me, like, no version of this has been good. Right, like, literally no version of this has been good. Even on the simplest possible version of this task, right? Crazy. It's completely unsatisfying to me that this behaves in such a manner. Like, how, right? How can it possibly... Try Pong. There are a couple things in my mind. We're not gonna admit defeat just yet, alright? 2048. One. Entropy. Okay, look at that. So that's very nice. Solve on Pong instantly, right? So this should be dramatically easier to model. Yeah, there you go. So that's only for one-step predictions, though. Not impressive at all. Okay? We're gonna build up from here. Can we run? Is it too ambitious if we just say, screw it, we use the full world model on this problem? Can we do that? We're not out of the woods at all. It's still like giga cursed. This 8. I mean, this is what I was like. My whole thing was uncurse reinforcement learning for like a good year while I was building up to Puffer 3. And we got it to work, but only in the high data regime, right? Okay, I mean, this does appear to be training, at least something. Not great, mind you. Does train. You should be able to do more mini batches on this, right? Magic. Yeah. I mean, a lot of the stuff I've written, right, helps kind of demystify a little bit. It's the reason it's black magic is not a good reason. It's that it's like the science and the engineering has just been done in a way that's incredibly crap. At least we have a version of this. Version of this that does work. The thing that I realized was that so the observations of breakout, like individual variables will change. Like so you'll have like 118 numbers or whatever, and like one of them will change. It's actually a kind of weird thing to do with just a mean squared error. Don't tell me this isn't gonna work now somehow. Really. What changed? No, it wasn't that. Heck is the difference? Okay, there isn't one. Noise. Fine. Fuchsia. Um, it probably needs to know its like its forces or something, right? Don't you need like you compute the force on the foot anyways, don't you? It needs all the information that you would expect to need in order to make decisions in the same situation. Try sticking your feet in a tub of ice for a while and then try walking. Don't actually do that though, you'll lose your feet. Okay, so it is dependent here on optimizing the heck out of the world model. Get courses. Oh, fair. If you want to get it on a real robot, you'd have to figure out what sensors they actually have and give it that information. Not optimized. You can't teach it much more directly without domain knowledge, though. That's the problem. Like, yeah, it's Breakout, so you could show it how to play the game. But I can give this thing a hideously complex optimization problem over which you have no intuition, and it'll just kick your ass. We use games so that we can understand what's going on, not so that the agent can. They don't. Humans are not tabula rasa. We are not blank slates. Humans have billions of years of evolutionary priors baked in. I mean, we have access to a truly ludicrous amount of high-fidelity data as well. There are a lot of differences. Okay, this is promising. You show your current setup. What do you mean? Oh. Yeah, not really the way this is set up. It's just like a random office. I've got this ring light down here where I can't even clamp it to this desk, so this is just sitting here, like blinding, you can see. Then I've got this boom mic arm over here. I've got one vert monitor here, one horizontal monitor, and I've got like a small desktop on the desk. That's about it. What happened to this? It crashed. Destabilized, huh? Dang. I am starting to lose faith in this approach a little bit. At least as a smooth scaling thing. It seems to me like these approaches are fundamentally going to take a lot more compute. It takes quite a bit to train the world model. I'm gonna have to do some thinking. Get out of here, bot. Get out. Start a series of live instead of random developing. Instead of randomly developing. Yeah, you don't want to slow the process down is the thing. Like, do you realize the implications of if any of the stuff I'd done in the last couple weeks had worked? So basically, if I solve this problem that I'm trying to solve immediately, um, it pretty much puts RL. I mean, it's like billions of dollars worth of use across industry is what it would enable. I mean, more than that, though, like, it would actually make RL like a really generally useful tech. If I just get some version of this idea to work in Puffer, like with Puffer quality engineering and stuff, it's not a small thing. The world model is just so unstable. Yeah, exactly. Uh, that's so obnoxious, so that it doesn't. Yeah, we avoid the politically adjacent slogans. I try to keep all my content purely science. With some small detours for fitness, because it's good to keep people in shape. I have gotten many people to actually start exercising again, which is good. Did my 10K today, was fastest time so far this training block, 106. Is slow for a 10K, but it's a very hard course. So, and yeah, this is true. The problem something is that the work I'm doing right now, it's like building new M's and stuff is the easiest spot to get new people involved. This stuff is like really freaking hard research. How fast does Streamer run normally? How many times faster would Puffer be in comparison? Oh geez, like 10,000 times? Is that right? No, more. Times 100,000? Somewhere between 10 and 100,000 times. Dreamer's slow as hell. So basically, yeah, FBR, this is the thing that I'm worried about, right? Is that, like, it's not like, oh, none of these world model approaches will work at all, but I think it's like, I don't know if there's any version of them that work without just ludicrous quantities of compute. Like, I think that basically what happens, and I think that what I figured out is that these world modeling approaches, they get data so slowly that the world model really doesn't need to change that much very quickly, right? Because the data stream is changing so slowly. And they're using like a ton of compute for training the world model. And if you're getting data faster, it's really difficult to keep the world model up. I actually have done that a few times, Jess. For whatever dumb reason, the Restream has it, but it doesn't work with over 3-hour streams, and most of my streams are over 3 hours. Yes, our PPO, no, our PPO implementation has genuine algorithmic contributions as well. There's an article on it on X. So we have the best high data regime RL. Really not liking this direction now. Let me try like this. Then we're gonna say 512. Use the restroom real quick, and then I'll think about. I gotta think about this stuff. This is just so incredibly obnoxious. And it's still unstable. That's so obnoxious. Holy hell. This puts us in a really tough spot. What's the goal for PufferLib 4? Bridge the sample efficiency gap. So, like, basically have the algorithm be such that you can smoothly invest more compute in order to get better results with less data. It's crazy that basically the only thing that we have that actually works is large batch on policy RL. That's what we have that works. So off policy, I mean, I think I've gained some valuable information at the very least, some very valuable practical information. On policy, large batch RL, it works. The only problem, right, is there's not a good way to scale it to use more compute and less data. You can't revisit old data. That's the big problem. Off policy RL. Off policy RL is a fundamentally worse algorithm. You use fundamentally worse algorithms that are more scalable. Because you can't do like a nice clean bootstrap. Single step diffusion. You're looking at image-based stuff. Not really for state-based stuff here. If I just add a replay buffer for the world model, is this good enough? It probably is. Based sort of environments. A lot of them, right? Any sort of high fidelity simulation, a lot of games, maybe some logistics, so I can probably make that fast. A lot of robotics, like high fidelity robotics. The problem is there's just no in between at the moment. It's like Puffer is good in high data regime, or you use the like god awful algorithms that are slow as molasses. Do not like. It's just so bad. Like such a bad spot for the field to be in. Could you restate the problem? Sure. The problem, I mean, the overall problem that I'm trying to solve here is how do we have an algorithm where we can spend more compute to get the same performance or better performance with less data, or we can spend more data to use less compute? Current roadblock. Um, the fact that the world model's kind of just crap, and it's tough. I'm gonna give it a little bit more time, but like the world model's kind of just crap. Honestly, this can just stay the same, can't this? Let's see what this does. Now the world model is being trained with a replay buffer. We'll see if that stabilizes it at all. Well, it helps. I mean, I guess that makes sense. I still don't know if we can do unlimited RL though, right? Wait, with the RMS? Like was it recurrent state space model, RSSM? What paper is that? Is that Original Dreamer? Hang on. Yeah, this is an LSTM. It's fucking Pong. You're predicting 4 numbers. It should not be hard. You know? It should not be hard. We'll see whether this changes it. So I messed with the RSSMs in the context of Dreamer. Really obnoxious architecture, mind you. I think more so what was happening was it's not like the architecture's not expressive enough to predict literally the 4 numbers representing Pong or whatever. I think it was just that the world model needs to really not be trained with just on-pol data. It really needs a buffer so it doesn't overfit. I don't think that's going to be enough to do breakout. We'll see. We still crashing. I mean, I guess now we can do more updates on the world model, right? Without overfitting. Why would you remove the recurrence? We'll see whether this is stable. The SPS is depressing. We'll see if it's stable. See whether we get a solve out of this. At the very least, this is better than what we had before with stupid Dreamer, right? Quite possible I need to increase the replay buffer as well. Yeah, it's unstable, damn it. Still unstable is crazy. Keeping all the data now. So now it can't forget. Well, I have a whole bunch of, not a whole bunch, but I have some meeting stuff tomorrow. I have some meeting stuff to deal with tomorrow. I will try to get a stream in the afternoon. I'm glad at least I got something to work. Ahem. Oblige me by working. Thank you very much. Model. Oh, zero entropy again. What? It zeroed the entropy on that? No way. Oh yeah, this literally can't be different. It must be unlucky. Because it can't drift apart before 5 mil steps, right? I have no idea what the heck is wrong with this, but we can at least go back to this one. So this is this version. Curious as to whether this does anything meaningful. Come on, give me something to show. Can it learn on its own imagined data, or will it overfit? You can't train the world model on its own imagined data, no. Entropy is way too high. And the only other option, right, is to solve off-pol. What? Like, the only other thing I can see, right, is to actually, at an algorithmic level, figure out the on-off-pol schism. It's quite hard. No idea what you're saying. Polymorphist. Is that even a real word? Combined polymorphism and theism. No, that's literally, you just put two words together. No polymorphism. No abstractions. Well, whatever I've done here, I've screwed the value function up massively, right? We can probably leave this alone. At least I can say that we got decent perf on Pong. I mean, to be fair though, like, this was the exact potential problem that I anticipated with world model stuff in general. Is basically like the best version of this I can see working at this point. You need to invest. It's not like you can add 50% more compute and you make it work better. There's a minimum threshold. That's so bad. Leave that going in the background. Like, value function is also dependent on the current policy, right? Oh. Well, that's non-trivial perf on breakout. So, that's something at least. Anything above 7 is non-trivial. Not great. But that's the literal first model-based thing I've seen do that. I'm trying to think what I should even start looking at. Oh, this is efficiency, or I don't even know why I'm looking at this. The problem is that the only stuff that actually works is based on... Where is it? Where's the derivation? What? Why don't they have... Did they remove the derivation from this page? Man. They removed the derivation. I think, yeah, there was where there used to be a derivation. And Lin Wang's RL's like fine, I think. Yeah, so this. You don't need to use a Q. This is a weird version of it. A spinning up used to have a good derivation. I don't know what they did with it. Oh, here it is. Yeah, this is the derivation. It's like 6-line derivation. In eh, we OOM on the buffer, but that's fine. I actually still is the correct mathematical interpretation of the on policy requirement that because off policy trajectories become increasingly unlikely under the policy, the gradient vanishes? Is that the correct interpretation? I mean, I'm trying to think what else we do here, right? I need to have like an absolutely perfect, I think, understanding though of the for once I actually need to have a perfect understanding of the math, and specifically I need to know exactly where and how on policy assumption comes into play. I have a good understanding, but not a perfect understanding. Hmm. Well, I have some reading up to do. I got a meeting tomorrow super early. I'm gonna go get some dinner. We got a result. We got a pretty clear result as well. It makes a lot of sense in context now. I suppose this was always going to be the result, right? Alright, well, folks who've been watching here, this is how research goes sometimes. You get a result, it's not the result you're hoping for. If you're interested in my stuff generally, puffer.ai for all the things. Try the repo, it's free, it helps me out a lot. Join Discord if you want to get involved with development, it's all open source. If you're looking to get into reinforcement learning, you can follow me on X for lots of content in that space. Thank you, and I will be back